some help, so we contacted our friends at Defy. They are kind of advancing the field and have some of the best exoskeletons that have been developed. They are really excited about partnering. I think they have some early success developing kind of a jumping style controller. They wanted to turn the control reins over to us, and we'll use their hardware, and we'll develop a system that hopefully can do some pretty neat things.
In high school, I was the state champion for Michigan, and then in college, I've gone to Big Tens, I think every single year. I mean, I've been training since I was like 10 to go as high as I can, so they're gonna have to make sure that they can get as explosive of a robot as possible. I personally do not think the robotics team will be able to beat me in jumping.
The pressure is, we know it's possible. They've shown it, I've worn it. So now we have to kind of step up to the plate and develop that system, hopefully maybe even a little bit better.
All right. Oh.
Nice.
You can't really tell, like, we want the spring torque when we squat down to be like high enough that it's applying torque, but not so high that it's pulling your ankles far off the ground, because then it's hard to get the angle you need to jump. You can think of it as like loading a spring and then you let the spring go and it just explodes into the air sort of thing.
It would be like loading it and then letting it go, but when you let it go, you start up from a compressed amount even further. So you get a boost of energy. But also I think like in addition to solving the control problems, a big challenge we're going to face is how to provide the torque in a way that's helpful. 6.
Sweet.
The overarching plan is to have the exoskeleton act like a spring at first, and we'll do that until we're really comfortable with that. Then we'll start adding net positive mechanical energy. So actually like turning into a motor, trying to actually boost the person up beyond what a spring could do. I think this challenge is important for a few reasons. I think it's good to get robotics in the spotlight. I think it's good to demonstrate areas of robotics that are accessible and interesting. And then I think it's good to showcase areas of robotics that require the human and robot to cooperate. And that this is an excellent version of that. The human and the robot have to operate together to increase someone's vertical jumping height. They can't be two separate systems. They're intimately coupled, and the person has to kind of leverage that system to get what they want. And so I think that's a really important thing to showcase in robotics as well.
I was really happy with what they did. Both of our jumpers got 2 extra inches.
I was shocked. I was like, wow, okay. Especially with jumping in those shoes and all that, the fanny pack and all that.
We decided to design this as a fun entertainment thing and hope that in the future it could be something that improves mobility for people, you know, maybe in combination with walking or running, something like that.
These exoskeletons were actually designed to help someone increase the efficiency of their walking, so they make you burn less calories. The idea being if you burn less calories, you can walk for longer or carry a heavier load and not get as tired. Beyond that, though, of course, we've seen a lot of success for exoskeletons to restore someone's ability to walk if they suffered a debilitative stroke or a disease akin to that. So I think the future's pretty bright for this technology in that respect as well.
There's certainly a lot of things we can do with them that I think we're just getting started with. So you can imagine an exo that's helping you, but you could also imagine an exo that does the opposite and makes you train as like a resistance exo. So there are all sorts of things that you can do in the rehab space to help you recover faster.